Hi everyone. Good morning. Thank you so much for being here. My name is Udochi Nwobodo. I'm a security engineer. I live in Seattle actually. I've been working in the field for about 5 years, and I want to say thank you to all for being here to listen to my talk, and also thank you to the BSides Philadelphia team for making this possible. So just as you can see, my talk from POS to PCI, translating Kubernetes security for security audit and compliance. I have to start off by apologizing. This is not a talk about Kubernetes security specifically. I don't know why I assumed everyone was familiar with Kubernetes security, maybe because I work there, but basically, while working, I've noticed that there's a lot of miscommunication between the Kubernetes teams and the security audit and compliance teams trying to execute audits, especially in cloud-native environments. And the point of this talk is to kind of like help both teams understand each other and sort of like achieve a shared and common objective. So, and even though this talk talks about like PCI, it's not restricted to the PCI compliance framework. It can be applied to other security compliance frameworks like SOC 2, FedRAMP. So just putting that for now. Okay, so why this talk matters? Just like I mentioned, on one hand, we have Kubernetes engineers. On the other hand, we have, we have security compliance, and then we have security audits. All the teams are trying to, the security audit team is trying to like obviously achieve security audits, and they're asking the Kubernetes compliance team for evidence, but both teams don't really understand each other, and so there needs to be like a middle ground for both teams to be able to communicate. So just looking at the example up here, so this is a Kubernetes security context, which basically says that a Kubernetes pod should not be able to run as root, and that the capabilities for any user should be restricted. Sorry, that sort of threw me off. That the capabilities for every user should be restricted. But when an auditor is asking, so tell me how you are implementing this privilege in your environment, they might not really understand this if you like show them the screenshots, even though basically this effectively implements this privilege in a Kubernetes environment. So basically, trying to get both sides to see each other and understand each other, that's what this talk is about. So basically, if you look at this table, like I mentioned, if you're familiar with Kubernetes or familiar with things like port security, network security, RBAC, compliance auditors are thinking about how you're implementing access control, how you're implementing network segmentation. Both sides might not know that they're speaking about the same thing. So basically, this table is sort of giving you an understanding of how different PCI, SOC 2, FedRAMP requirements are being met in Kubernetes control, even though they might not really apply to like the native language of like data centers, firewalls that are more familiar to the traditional security compliance professional. More examples here. So just like I said, because both sides work in different fields and they don't really always understand what each other is saying, it's best to meet at the middle ground. And what exactly does that mean? That rather than saying, oh, how are you meeting PCI 6? Or, oh, we have RBAC for implementing IAM, both teams can come together to talk about security objectives. So I feel that the collaboration between both teams will be more productive when you're talking about security audit compliance in terms of like access control, change management, audit logging, vulnerability management. These are things that both sides can really talk about and understand and sort of like bridge that understanding gap between both teams. So hopefully by the end of this talk, the takeaway of this talk should be that you should be able to apply these mappings when you get back to your offices, especially when it's like if you have an upcoming SOC 2 audit or an upcoming PCI-DSS audit. This should be a framework you're able to apply so that both sides of the aisle are able to understand each other and achieve the right security audit in the cloud-native environment. So I'm just going to start digging into different security controls and talking about how they map to Kubernetes. So right here, we have access control in Kubernetes. When it comes to Kubernetes, how do we achieve access control? So we have roles and cluster roles. A role is basically what a pod is allowed to do. A cluster role is what is allowed to do across an entire Kubernetes cluster. And then role binding basically binds a role to a pod just so that, kind of like least privilege in a more traditional environment. What is a pod allowed to do? That is defined by the role that it is bound to. And also service accounts in terms of the Kubernetes workloads. These are the identities that Kubernetes workloads have, in the Kubernetes cluster. We have like namespace, when you talk about logical isolation, separation of duties, things like network security, separating boundaries, boundary controls. That translates in Kubernetes in terms of like namespace and network policies. When you think about things like change control, how is change management managed in a Kubernetes cluster? We talk about things like admission controllers. And in terms of like audit and logging, which is obviously like the central issue when it comes to security compliance and auditing, we can think about Kubernetes API server logs. So just to show, say, you have an auditor come in and say, oh, you have this service that is running in a Kubernetes cluster. We need to get security audit evidence in terms of like how are you implementing identity and access management. These are some of the evidence types that you could provide in terms of like, what is the RBAC YAML snippets, what are the output of kubectl, thinking about things like opaque, Gatekeeper, how was those policies enforced, and audit logs. So just to show an example of this, in real life. So here we have created a service account. We are calling that the audit reader. And just so, this shows like, the configurations of that service account. And then, that is the role binding. So basically, trying out like, running these pods, using this service account role bound to it and trying to like get secrets, especially when we know that the service account lacks the permission to get secrets. We can see that that is an error. That doesn't work. So that is something that in terms of like, if an auditor is asking, okay, what is identity and access management? How are you enforcing identity and access management, least privilege in your Kubernetes cluster? This is an example of an evidence or like, what you can think through in order to demonstrate compliance towards that compliance objective. And then moving on, the next security control is network segmentation. So basically this is talking about, obviously in traditional security, we have firewalls, we have VPCs, sensitive workloads should not be able to communicate with non-sensitive workloads. This is a very core requirement of PCI-DSS. And basically this is how it's implemented in Kubernetes. And we do that using network policies and namespaces. So these are some of the evidence you can provide. Say if an auditor is asking, so how exactly is network segmentation, and isolation being implemented in Kubernetes clusters? We have like the network policy YAML snippets. We have like the kubectl output of network policies. We can also test, we can like test interconnectivity between various pods and screenshot that as evidence for something that can be applied towards the security audit. Here we have more of that, audit trails, logs, namespace boundaries. And just so this table is basically like helping you understand how exactly the various PCI-DSS requirements map to actual Kubernetes features. This is kind of like a framework you can use when you're thinking about, okay, how exactly do we show that we are complying with the network segmentation requirements of PCI-DSS, SOC 2, FedRAMP. These are some of the things you can think of in terms of like working with security auditors to meet those objectives. And then just to show another real world example. So for example, here we have, we have like 2 pods in the Kubernetes cluster. By default, without any like security implementation, these 2 pods can communicate with each other. And obviously that goes against security compliance framework requirements. And then when we apply a network security policy, we see that that connection is blocked. So this is another example of an evidence that can be provided towards the security compliance auditors. Then moving on to pod security, basically we're trying to say, when we think about a pod in a Kubernetes cluster, what are the security capabilities that those pods can perform? For example, can they run as roots? What permissions are being assigned to them? What elements within the Kubernetes cluster are they able to communicate with? And all this is sort of like collocated in the configuration that is applied to a specific Kubernetes pod. So again, obviously, just like we've spoken before, what are some of the evidence you can provide in terms of like when a security auditor is asking, okay, how exactly is pod security being enforced in the Kubernetes cluster? We have the pod security admission configuration. We have audit logs. We have like the specification of the pods. Basically, what are the configurations that are being applied in Kubernetes to control the security behavior of these pods. And those are examples of like evidence that can be provided to the security auditor. And just so again, trying to place an understanding between the actual compliance requirements and what that means in the actual Kubernetes cluster. This is like kind of like a framework that you can use to think about that. And then here we are seeing a real-life application of this. So basically, the PSS restricted is a restrictive pod security policy. Basically, we are seeing like the labels here, like, what is prevented from being locked down. And then we are seeing that, for example, in this pod, when we see things like, this is a privileged pod, so it allows escalation of privilege. It basically has capabilities to do anything, so there is no limiting of duties, and it can run as the root user. Obviously, this goes against security configuration best practices, and then we see that when we run this pod, we get an error because it goes against our secure pod configuration. Same here, the error, and then we see that when we explicitly provide good security configurations, not running as root, not allowing privilege escalation, limiting the capabilities of the pod, then the pod is able to run properly. So these are examples of evidence that we can provide to security auditors when asking about, how well we have implemented security requirements in our Kubernetes cluster. So moving on, image security. So basically, this says that, the image, obviously Kubernetes is based on images that we deploy in clusters. What sort of vulnerabilities do these images have? Are they vulnerability free? Are they clean? What can they introduce to the vulnerability cluster? This is a very important component of both Kubernetes security and Kubernetes security auditing. And just looking at this tab, we can see some of the evidence that points to show that we are using the right and secure images within our Kubernetes cluster. We can see in terms of like the admission controller, we can see field deployment logs. Like for example, when we create secure admission policies that restrict unsafe images, when we run unsafe images, we are going to see evidence of that in the log. And that is something we can provide to auditors to say, okay, this is evidence of how we have enforced proper image scanning policies. This as well. So just, again, another framework to understand how different individual compliance requirements map to evidence types and what you can be thinking of when you are the person that's at the other end responsible for providing the evidence to meet a specific security compliance audit. So just here, another real-world example, being able to run a trusted image and an untrusted image. This is evidence that obviously we have a clear security policy running that blocks untrusted images. So this is an example of an artifact that can be provided for Kubernetes compliance. Same here. Then moving on, another important part of security compliance is change control. Basically, who is allowed to apply changes, are changes being tracked, are changes being audited, who has the permission to make changes. That's a very core part of security that applies to both PCI-DSS, SOC 2, and FedRAMP. And then looking here, some of the things that we can think of are, okay, let me just speak a bit about Kiveno and Gatekeeper. opaque, Gatekeeper, and Kiveno are tools that we can deploy in our Kubernetes cluster that sort of act as gatekeepers in terms of like what actions are being allowed in a Kubernetes cluster. So for example, say we don't want anyone that is not an admin changing IAM rules in the Kubernetes cluster. We can create a gatekeeper policy that blocks that. And that doesn't just serve, obviously, as a security control, but that is also an evidence of a compliance artifact that we can produce to say we have implemented effective change control within our Kubernetes cluster. And so that is a very good example of that. We can also look at our audit logs in terms of like what is rejected. If you're using like a GitOps pipeline, you can also look at your logs in terms of like evidence of what has been rejected by the Kubernetes controller in the cluster. That gives a good idea of what change management looks like within the Kubernetes cluster. Same here as before, just mapping to various requirements that apply to change management. So here we have an example of an admission controller policy. In this example, for example, we don't want to use the host network and modifying rules is restricted. And then when we run a bad, a pod that sort of goes against these policies, we see that that is rejected. So that's an example of an evidence that we can provide during a security audit of a Kubernetes environment. So moving into the final control, one would say that this might be the most important security control when it comes to security compliance auditing, because auditing obviously is trying to understand what happens within the environment and how does that meet our security objectives. And the primary source of data for that is in audit logging, it's in our audit logs. So basically, what are some of the evidence that can point to this? We have our Kubernetes audit log that records everything that happens within the cluster. We have our audit policies. We have obviously we can collocate our evidence in our SIEM log streams, and not just about collecting evidence, but also what is the retention of that evidence, and how can we rely in the integrity of that evidence. And that is where log retention comes in. And then looking at how that traces across the various PCI-DSS compliance requirements. And so coming to this stage, I know this has been quite a lot. I know lots of people don't work in audit and compliance, and this is a very niche, what would I call it now? A very niche talk, focusing on people that are doing audit in a Kubernetes environment. But even if you're a security engineer, you don't necessarily work in audit. Someday you might be tasked with working with the security compliance team and helping them gather the documentation and evidence that they need to complete an audit. So this might be some of the things that you might be thinking of should that day come. So talking about some of the pitfalls in terms of this, again, like I mentioned, people that are working in engineering don't understand what people in compliance are talking about. People that are in compliance don't understand what people in engineering are talking about. So both of them are not speaking the same language, and there is a lot of misalignment, which leads to a lot of inefficiencies. And also talking about static snapshots, traditionally in security auditing, you're bringing out like snapshots, like things that were done in point in time, but that is not how Kubernetes works. It's ephemeral, it's always changing, it's always generating many logs per hour, so that is something to think of in terms of, as opposed to providing static evidence, thinking about how that evidence can be continuously monitored, for better audits. And then ignoring the developer context, again, this sort of speaks to the first topic in terms of like both sides not understanding each other. If a compliance person is coming in and asking to execute an audit in a Kubernetes environment, but they don't really understand how the DevOps team works, how the software development lifecycle processes work, they're going to have a hard time really trying to get the evidence that they have. So there definitely needs to be a lot of empathy and understanding between those teams. Obviously, talking about logs, again, like I said, a very key part of executing a successful security audit. Lots of times these logs do not exist because teams are focused a lot on like the operational velocity of the teams and not really thinking about observability and security compliance. So those are things that should definitely exist and should be used all the time. No defined audit scope, controls. Okay, so this is something that is really important. Like a lot of times people could be like, tell me how you have, say, implemented network security in this Kubernetes environment. And the engineer can be like, oh, we have network policies, that's not a big deal. And that's great, like in terms of a security perspective. But audit is about getting attestable evidence that will help the company meet its compliance objectives to still be in business, which means that the security audit team needs actual physical evidence of that security control. So that definitely needs to be emerging in terms of like a theoretical understanding that security has been implemented versus like the physical aspect of providing that evidence to show that that control has been met. And obviously, again, compliance as an afterthought, sort of tying back into the first and the third topics, they should be brought into the part of the process. Normally, people deploy services, deploy applications, and then whenever it's time for like SOC 2 audits, everybody's like running around trying to gather evidence, but that is kind of counterproductive. The security compliance team should be part of the design and planning process right from the beginning of a Kubernetes design down to the end, just so that they have visibility into how that system works and the audit process can be more efficient. So what are the key takeaways from this? First of all, again, having both teams understand each other, not speaking about, oh, we have a network policy, we have an admission controller. What exactly does that mean in the security context? What can both sides understand? Both sides can understand network security, change management, vulnerability management, image security. So that's a better context to talk within. Mapping evidence to outcomes, again, just like I mentioned, it's not enough to have security controls. They have to be evidence, they have to be attestable. So that's something to work towards. Preventing before detecting. Again, lots of Kubernetes applications are collocated within the DevOps team, which is not necessarily a security team. So security usually comes in after an afterthought. And so security should definitely be included in terms of prevention and when systems are being designed, as opposed to like including them as an afterthought. Auditor empathy matters. I mean, if I was going to summarize this entire talk in one thing, it's definitely going to be that point. Auditor empathy matters, having both sides understand each other, having both sides to work towards one goal. Auditors are more management governance, not very technical. Engineers are very technical, don't have patience for the management governance side. Both teams need to work together and both teams need to understand each other. And obviously, compliance is continuous. It's not just one thing. It's not just, oh, this is SOC 2 audit time. Let's do that and move on. These are things that you should be continuous in terms of like, do we have systems in place for gathering evidence? Do we have controls in place that will, that we can discuss during audit time? It's kind of like, I know I'm sort of like differentiating security from audit, but just the way we talk about, DevSecOps, embedding security into like the DevOps CI/CD pipeline. That security should also include like security audit, how exactly would the security controls we've implemented play out in terms of like when an audit is needed. So just a takeaway from this, what can you take away from this talk? I know that, I'm not going to lie, Kubernetes is like a very niche topic. Lots of people are hearing it for the first time, but it's not something that you have to tackle all in one place. You can just start with one control, just and expand from there. Think about tools. You don't have to do this yourself. Kubernetes is a very complex and could be intimidating platform. So think about, some of the tools that you can use to make your work easier. And again, I feel like I keep repeating it, but empathy between those sides, collaborating, coming together, understanding each other, those are definitely some things to think about and take away from this talk. So just in case anyone wants to learn more about these are some like really good resources for like really understanding more about Kubernetes security. Again, I understand this is a very niche topic, but as companies, everyone is talking about AI now, cloud native, working on the cloud. These are things that are going to come in to your workplaces if they don't exist now. So these are some things to be thinking about just in case the time comes when you have to work in this area. So yes, that's it. Thank you so much. I know it was a little bit of a niche topic, but thank you. Thank you a lot.